Hey guys, so here's the notes for our Unit 4 Lesson 11. We're going to be modeling polynomials using a graphing calculator. So you definitely need to make sure you have a graphing calculator with you to do this. Okay, so finite differences. This is used to determine whether y values for equally spaced x values can be modeled by a polynomial function. So you'll kind of see, like in our example 1, you'll notice our x values that they're equally spaced. So it's 1, 2, 3, 4, 5, 6. So they kind of go at a difference of 1, okay? Now, example 1 asks us, show that this function has constant second order difference. So what that means is that, well, really that would be our polynomial of a second degree here. So what that means is that we're going to have a quadratic, okay? Now, in order to have a constant second order difference, that means when we subtract or find the difference, that means it has to be constant, right? So it has to be the same value. So we're going to subtract our y values. So basically when we do this, we're not going to do 1 minus 3, but instead 3 minus 1. So that gives us 2. Then I'm going to do 6 minus 3, so that gives us 3. Then 10 minus 6 is 4. And then 15 minus 10 is 5. And then 21 minus is 6. So notice here, right, the values are not constant, okay? Now, it did ask us for a second order. This is what we call a first order. So when you do the first time, okay? Now let's subtract these values. So 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, and then 6 minus 5 is 1. So here we get all values that are constant. Here's our second order difference, okay? Now, when they say show, that means, well, you should have that value, right? We have to have a second order difference. So if you don't, then you kind of have to rethink, okay, what did I do wrong here, okay? And so this is what we would call a degree of 2, okay? So whatever your order difference is, that's the type of degree of it. And as I said, that's going to represent a quadratic polynomial. Okay, so let's look at example 2. It says, show that the nth order difference from the given function of degree n are non-zero and constant. So what this means is we are going to have a polynomial, but we got to figure out, well, what is that polynomial? What is the degree? Is it a first order, which means that would be a linear, first or degree of 1? Is it a second order? So is that a degree of 2, so quadratic? Is it a third order, so degree of 3, which is a cubic, and so on, okay? So here, what we need to do is actually create an XY table. So I need to do my X, and I'm going to do my y. Now you can do x or f of x. Well, you probably want to use what they have here. So I'm going to use f of x. Okay. So here, our x values, we're always going to start at 1 when we do this. Just like when you see basically our example 1, we started at 1 and then went to boom, 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 boom. So remember your x's are going to be equally spaced. So we just do 1, and I put that 2, 3, 4, 5, and 6. And you want 6 points, okay? The reason being is that that's going to give us a good amount. If we even get to even a fourth degree difference there, a fourth order difference, that will have enough values to know if it's constant. Now, if we have these x's, how do we find our f of x? Well, you take your values, you plug it back in to your equation. So where we see x squared minus 3x plus 7, you're going to take your 1 and plug it in for where you see x, okay? When you do that, you should get 5. So you can just plug it right into your calculator. Now, when we do 2, you do the same thing. So you have 2 squared minus 3 times 2 plus 7. You can either just plug it into your calculator, which that's what I would suggest. That does give us 4 minus 6, which is negative 2 plus 7. That gives us 5. Okay, then when you plug 3 into your calculator, you get 7. Then 4 is an 11. 5 is 17. And then 6 is 25. So all you're doing is taking your x's, plug them back into the equation, okay, and then getting the y's. So now we need to do the difference. Now here, right, it says show that the nth order difference from the given function of degree n are non-zero constant. Now notice what our degree is here for this function. We have x squared minus 3x plus 7. What is the degree of this function? Well, the degree is 2, because what's the largest exponent? 2. It's a quadratic, right? So what that really actually means here is that we need to make sure that we get a second order difference. If we don't, we did something wrong, okay? Because basically whatever your order difference you get, that is the degree you should have on the polynomial. Okay, let's do 5 minus 5. That gives us 0. 7 minus 5. So remember, when you subtract, you take that second value, subtract it from the first. Okay, 4 minus 7 is, or sorry, 11 minus 7 is 4. Already gave you the answer there. 17 minus 11 is 16. And then 25 minus 17 is 8. Not 16. It is, excuse me, sorry, I'm not even doing my math correctly here. It is 6, and this is 8. Sorry, guys. Okay, so now we subtract again. We have to get a second order difference. So 2 minus 0 is 2. 4 minus 2 is 2. 6 minus 4 is 2. And 8 minus 6 is 2. Hey, we get all constants here. So we do get a second. So this was our first here. A second order difference. And when it says show, right, we're really, if you think about it, we are proving that this is correct, right? We have like a thesis, we have our statement. Now we have to kind of show support. This is our evidence here, okay? Okay, so now we have this next example. And actually what I would like you guys to do is go ahead and pause the video and try example 3 on your own. So go ahead and do that. Okay, let's see what you got here, okay? So notice on our polynomial, the degree, okay? Remember degree, in this case, because we are in standard form, I forgot to talk about that in our example 2, but notice because we are in standard form, our degree is the highest exponent. So here, our degree is 3. So since our degree is 3, we should get a third order difference. If not, well, we did not do this correctly. Okay, so remember we need to do an XY table. Okay, so I got X. They use f of X, so I got to use that. Kind of use what they give to you. And remember, we're always going to start at 1 here. So I'm going to do 1, 2, 3, 4, 5, and 6, okay? And you always want to go up to 6 because that gives you enough, especially with your third degree. And if we ever get a problem where it's a fourth degree, you get enough, okay? Now remember, to get your y values, your f of x, you take your x's here and you plug it back into where you see x in the function. So we should get -4, 2, 34. So these values will get large a little bit. 110. Ooh, that looks really bad there. There we go. So we get 110, 248. And then 466. We're going to do some subtracting. And as I said, use your calculator. That is okay to do. Okay, let's subtract 2 minus a -4. Be careful here. That actually gives us 6, okay? 34 minus 2, that's 32. Okay, you can do this in your calculator. This will give you 76. And then we get 138. And then 218. Okay, let's keep subtracting. So we do 32 minus 6, that's 26. 76 minus 32 is 44. 138 minus 76, 62. And 218 minus that, we'll get 80. Okay, now we subtract again. So from here, we get 18. So 44 minus 26. 62 minus 44 is 18. And then 80, 62, that's 18. So notice we get our first, second, and then our third. So we did this correctly because notice that all our values are constant, right? So just like we did it here, all of our values were constant on that second order, okay? Okay, make sure you keep working. I'm going to go to the next part here.